Good morning, everybody. Hopefully you're all doing well today. You can start with some green check marks, please. I'm very pleased to report, I shouldn't say this. Put your green check marks in first and then I'll say it, just so I don't ruin things. Okay, I have one green check, that's probably good enough. Last class, things were a disaster. Chat wasn't working here and my Blackboard wasn't working there. But everything seems to be working this morning. So the microphone works. Life is good. Aaron, nice to see you in and see that things seem to be working for you. You got a new computer and it worked out right away, or you're using the old one. Awesome. So wait on Connor and Jesse for green checks, and then we'll get started. If you guys ran into any problems last class on this, we were doing multiplying and adding, subtracting radicals, and we left you with some of the questions out of the learning guide there. So if you ran into any troubles there, you want to throw them in the chat, that'd be good. I just want to mention, I added a couple sheets to the course. I'm not going to collect them. It turns out that we actually do this material later on once we get into polynomials. But for now, it just kind of, because we have to do this sort of stuff with the radicals, we need to kind of make sure we know how to use and multiply. And so I added a couple sheets. So it's in Unit 1. I put them way over here. Multiplying polynomials practice and multiplying binomials practice. I'm going to go through a few of these questions today, just kind of show you guys how to do this stuff. Some of you have seen this before, and it'll be a review, and others it'll be brand new. But we kind of expect you to be able to do it with radicals, and sometimes that's a big step, going from multiplying, polynomials to multiplying radicals. So we'll look at kind of really basic sort of examples, and then we'll kind of apply that to radicals, and hopefully that works out a bit better. So that's what I want to start with. I don't see anybody putting anything into chat, and I have chat turned on, so I haven't managed to mess that up yet. All right. Perfect. So if you don't need, there's not a ton of stuff on these sheets. It's pretty basic. I'm not going to do all the questions just because I want to finish up Unit 1 today. But those sheets are there. One of them has all the answers written down and the other doesn't. So I'll just jump into here. So we call this the distributive property of multiplication. And some of you, last day I said, have you guys ever heard of feeding the chickens? And some of you said, yeah, I've heard of feeding the chickens. And the idea is this. When we multiply something that's outside of the brackets by something that's inside of the brackets, so if you can kind of think along the lines of like monomials and binomials like we're dealing with here, and then we're going to transfer this whole idea into radicals in a second. So I just wanted to show you something you're kind of perhaps a bit more familiar with before we try to apply it to the radicals, because that'll obviously be new for us. So when we multiply something outside of the brackets by something inside of the brackets, everything inside of the brackets needs to get multiplied by the thing that was outside of the brackets. Now, I'll do a couple examples, and if you guys have any questions along the way, just ask. So the idea here is that the brackets on either side of this expression, you want to think of them kind of as like a fence. This is where the feeding the chickens thing comes from. So if this is a fence, the red lines I've drawn there, and you have the two things inside of the fence, these are your chickens. So there's this negative 8n and negative 7. The thing on the outside needs to get multiplied by both things on the inside, or you need to feed both chickens on the inside. I'm pretty sure this is a grade 9 idea that you probably have seen before, and it's kind of fun sometimes in class. People kill the chickens, really. They forget to multiply both things. So I get upset when you kill the chickens. We don't want to kill the chickens. So you got to feed the chickens, keep them alive. So when we multiply these things, you just multiply the numbers in front. So we go negative 9 times negative 8, and we get positive 72. And then n times n is n squared. So that's this first step here, the blue one. And I'll do the second step in green. So now we're going to go negative 9 times negative 7. We're going to get positive 63, and then n times nothing is just n. So when we have something in front of the brackets, it needs to get multiplied by both things inside of the brackets. When you get to the last step, or when you get to where we are here, you can combine any terms that are the same. So if I had an n and another n somewhere, I can combine those together. But in this case, we have an n squared and an n, which is a little bit different. So maybe in chat, you just want to type in if you've seen this before or if it's new, just so I kind of get a bit of an idea of how many of these I need to go through to make sure that everybody's on the same page. So if this is kind of like a brand new idea, you can just write a new. And if you're like Mr. Borden, I did hundreds of these last year, you could just type in like seen it, done it, been there. And if we've all seen it before, then I'll just move on after a couple. And if some of us this is new, then I'll do a few. Okay, so it's new for most of us. Seen it, new. All right, we're about half for both. So I'll do maybe like a few more of these, and it's pretty straightforward. If I wrote a question like something like negative 2t times negative 9, you guys would likely know what to do with that. You'd multiply the 2 and the 9, you get, positive 18t. All we're doing is just doing multiplication kind of twice, and then, if we can, combine it together. So let's do this next one. Again, whatever's outside of the brackets needs to get multiplied by both things inside. So negative 2 and negative 9 gives me positive 18, and then t times nothing is, or just a 1, I suppose, is t. So that's the blue. And then we have the green. Negative 2 times positive 9 is negative 18, and then t times t gives me t squared. Just remembering that it doesn't really matter what the variables are. It could be x, it could be y. They've just chosen the letter t. Sometimes we'll deal with Greek letters, alphas, betas, gammas, sigmas. It doesn't matter. They're all the same. If you want to put an x in there instead of a t, that's fine. Make your life easier by all means. All right, I'll do a few more, and then I'll kind of just, if you've never seen it before, we'll just check in and see kind of how you're doing. It takes a bit of practice, but it's not terribly difficult, I don't feel. Negative 3 times 6 is negative 18. And then b and b is b squared. And then I need to do the second one, feed the second chicken. Negative 3 times 6 again is negative 18, and b times 1 is just b. Okay. Moving along. Negative 7 times positive 8 give us negative 56, and then r times 1 is r. And then the second one is going to be negative 7 times positive 3 is negative 21r. Squared. I'd love to tell you it gets a lot more difficult than that, but it doesn't. That's basically kind of it. So there are additional questions on this page. If you've never seen this stuff before and you're kind of scratching your head right now, you can just work through these. The answers are all written here. You notice in the answers they've written them in kind of descending order with the squared and then the 1 next. So your order will likely be switched on a lot of them. That's not that big of a deal. That's just how they've chosen to write them. Yeah. For those of you that this is new to, is that going to be okay? Can we kind of mosey on to the next stuff? Or would you like me to go through more? I don't care. care either way. We'll definitely have time to get through everything I want to get through today. Nobody's interested in telling me to do more, so I guess we'll go on to something that I am pretty certain will be new for just about everyone. All right, so that's there, the sheet's there. Thank you, Jenna. If you do want to see a few more of those, or if you run into problems, you can always come back and look at these kind of basic examples. So when we throw some radicals in there, things get a little trickier, but the idea is the same. As long as you remember whatever's on the outside of the brackets needs to be multiplied by both things inside of the brackets, you're good. And I always refer to it as feeding the chickens. So if I say that, you don't think I'm crazy, you just kind of know what I'm talking about. That would be a good thing. It's a little bit small. Jumbo size it a bit. All right. Now, the questions we just looked at were one thing outside of the brackets multiplied by a binomial, or two things inside of the brackets. We're now going to look at what happens when we multiply two things in front by two things in the back. And I'm not going to beat around the bush here. We'll get right to it. We use an acronym. It's called FOIL. So F-O-I-L. I'm going to rewrite that. It's not what I wanted. I'm going to write it in different colors. O, I, and L. So the idea behind the distributive property of multiplication is that when we multiply, when we had one thing, a monomial out front, and then a binomial in the brackets, you had to feed both the chickens. So you need to multiply the thing in the front by both things inside. But what happens here when we have two things in the front and two things in the back? How do we ever do this? So it's the exact same idea. Everything in the first bracket needs to be multiplied by everything in the second bracket. And this little acronym, FOIL, just kind of organizes the multiplication so we do it in the same order each time. So that'll just make it kind of a little bit more standardized, and anytime you have two binomials, you're just going to go first, outside, inside, last. So F is first, O is outside, write the O again, I is inside, and L is last. So as long as we follow this process, we're going to always do these the exact same way, first, outside, inside, last. Then we will always multiply every term in the first bracket by every term in the second bracket. And that's really what we want to do. So I'm going to just draw in arrows, and then I'll actually do the multiplication. So first means I take the first thing from this bracket, and I multiply it by the first thing in this bracket. Then the O for outside means I want to take the outside thing and multiply it by the outside thing here. So I'm going to take the first thing and multiply it by that. So what I've done for the first two letters, first and outside, is I've multiplied the first term by both terms in this, essentially multiplied the first term by both terms in the second bracket. And then I have this inside I, which is the two inside things need to be multiplied next. And then the L means last, which is the last thing in both brackets need to be multiplied. Holy cow, Mr. Borden, that's confusing. Yeah, it takes a little bit of getting used to, but you should be able to do it, I think. It's not terribly difficult. So first, we need to take the first things and multiply them. So we have 3n times n gives us 3n squared. And then the next is O for outside is going to be the red arrow, the 3n times the 3. It's going to give us positive 9n. And then we have the inside is 2 times n is going to give us positive 2n. And then we have the last, which is the green arrow, the 2 times the 3 is going to give us positive 6. So first, outside, inside, last, I'm always going to end up with 4 terms. And there's always additional, I shouldn't say there's always, 99% of the time there's going to be an additional step because we have like terms here, this 9n and 2n are the same. I have 9n's, I have another 2n's, I can combine them together. So I have this 3n squared, the 9 and the 2 together give me 11n's, and then I have this plus 6 as well, just kicking around there. All right, in chat, has anyone seen FOIL before? Has anyone seen that process happen before? Anyone? Sometimes in grade 9, teachers get like a really strong class and they'll do a few extra things. Yeah, so Aaron's seen it before. Eric, perfect. So some of you guys have seen this. I have a feeling the same people who've seen the distributive principle have probably seen the FOIL, and then Leeds, you saw the other one, but you hadn't seen this. All right, fair enough. So just depends on who your Math 9 teacher is. Let's do a few more of these because they can get tricky. After a while, you get really quick at them, but for now, we'll just go nice and slow. So let's do number 2 here. First is going to be the first term times the first term. I have n times 2n gives me 2n squared. Just move that down a little bit, I suppose. First, outside terms. So the n times the negative 2 gives me negative 2n. I have inside for I. So I'm going to multiply this negative 1 by 2n. It's going to give me negative 2n. And then L, I did that in the wrong color. Get it together, Mr. Borden. First terms. What did I do for insides last time? I did black. Outside, inside. There we go, negative 2n. And then last terms is going to be this negative 1 times this negative 2. It's going to give me positive 2. 2 negatives gives me a positive. And almost always we'll have to combine our like terms in the middle. So in this case, again, I have this negative 2n and negative 2n, so I need to combine those together. So I have 2n squared. Negative 2 and negative 2 gives me negative 4. And then positive 2. There we go. All right, so I've done 2 here. I want to give you guys a little bit of time just so you don't just watch me do this the whole day. I would love it if you guys just maybe put up 5 minutes and you guys just do as many as you can. And I realize there aren't answers here. I'll probably do the first maybe 8. And then, so if you guys want to finish up to here, at the end of the class today, before the end of the day, I'll do all of these questions all the way down to 18 and I'll post answers up in Moodle for you guys. But for now, if you just want to try a few and just see how you do, and I'll do a few of them and then we'll kind of apply what we've done here to radicals, and hopefully it's a smooth transition. You never know. So here's 5 minutes. Good luck. Hi guys, welcome back. Let's do a few of these together and see how you guys ended up. I'll just do, like I said, maybe I'll do up to like 8 real quick. And then if you guys run into any problems or if I make a mistake because I'm going fast, just let me know. And once we get to 8, we'll kind of decide if we are ready to move into radicals or if we just want to see a few more. So instead of doing like the color-coded thing, I'll probably just stick with one color for now. I'll still draw my little arrows here though. So FOIL. First, 2 times 2 is 4, x times x is x squared. And then I have outsides is going to be 2 times negative 3 is negative 6, and then the x. And then insides, 3 times 2 is 6x. And then the last is negative 3 times positive 3, which is going to give me negative 9. This one's a little bit funny because the middle terms actually, turns out they cancel out. I have negative 6 and positive 6. And we'll use this fact later. This is what we call a difference of squares. See it again in a couple units. So 4x squared minus 9. So a bit of a trick to that one. This next one, number 4, r times r. So my firsts is r squared. Outside is 3 times r is negative 3r. And then my insides are positive 1 times r is just going to be positive r inside. And then my last is going to be 1 times negative 3, which is going to give me negative 3. I'm going to combine my r's together in the middle. Sound like a pirate. R squared minus 2r minus 3. And I'm done. Let's keep this rolling. 2 times 2, 4n squared. 2n times 1 is 2n. 3 times 2 gives me 6n. And then 3 times 1 gives me 3. Combining my like terms, 4n squared plus 8n plus 3. Whew. I'm on a roll. I'm going to keep going. 3p times p, 3p squared is my firsts. Outside, it's going to be 3p minus 1, so negative 3p. Inside, negative 3 times p, negative 3p. And last, negative 3, negative 1, positive 3. Combine like terms. All right. 3p times 3p is 9p squared plus 6p plus 9p plus 6. So 9p squared plus 15p plus 6. K squared minus 3k minus 2k plus 6. Combine like terms, minus 5k plus 6. All right, so there's the first 8. I don't mind doing more. We're going to do more with radicals, so you'll see it again. I just wanted to kind of do with variables first, just so we kind of, because adding radicals in just makes it a little bit more difficult. So give me kind of your feeling on this. If you're kind of okay with it, then that's a good thing. You know, you've only seen 8. Many of you, so I don't expect you to be experts on it, but it's just nice to kind of be able to refer back to this a little later on. So if you want to just throw something in chat or give me like thumbs up or a green check mark or whatever you want, just so I can get a little bit of a feel for if you guys want to see a few more of these or if we can move into radicals with the same idea. I'll say FOIL a lot. And I just kind of hope you guys know what that means. FOIL. 75 out of 100. Well, you give a thumbs up, thumbs down. That's kind of like a 50% type of thing. All right. 3 people are more or less okay. It does take practice. We'll see it again and again and again. So. All right. Nobody's like, help me, I'm lost. Anyone not feeling real comfortable with this whole stuff? it does show up in a weird spot in the course. Like they expect you guys to know how to do this right at the beginning, but then they don't teach you this stuff till like unit 4. There's no way to win. I've tried starting with different units before and it just never really works out. There's always something that needs another unit to kind of explain it. So there you go. I want to go back to lesson 4/5, which we were working through for the last couple classes. We did some questions, and then I said, no, we can't go any further because we don't know the distributive property of multiplication, so we couldn't do E or F. And being the foolish person that I am, or G for that matter, being the foolish person that I am, I forgot to put the second page on this that has some division questions. So I'm going to just have to add those in a second. Sorry about that. So let's do letter E here. And letter E, it turns out, is a feeding the chickens question. It's the distributive property of multiplication. We just did questions with variables, so if we had like x times x, we got x squared. But now we have radicals. So if we just take a step backwards for a minute, we were multiplying radicals up above here. And we said, if I'm looking at letter C here, I said if I multiply root 3 times root 3, I just multiply whatever is under the radical sign together. So I got 3 times 3 is 9, and then I took the square root of 9 just because I could. If I look back even further to letter B up here, all these boxes, I multiplied whatever number was in front by whatever is in front, so that was the same as the variables, and then whatever is under the radical sign by under the radical sign. So root 2 times root 2 gave me 2 times 2, which gave me the square root of 4, which happened to be 2. So we're going to kind of put what we just talked about together with what we talked about last day and see where we end up. So I'm going to show a ton of steps for these first few, and then after a while I'll maybe just go a little bit quicker. So when we talk about the distributive property of multiplication, we need to multiply the first thing by the first thing. And we always know there's kind of like a 1 out front here, but we don't write it in. So that would be like this 1 times the 2, or just 2. So I'll just get rid of that. So I'm going to end up with a 2. And then root 5 times root 3, I'm going to put them both under a radical sign. Just kind of show how that works. I probably wouldn't normally show that step. So if you don't show it, I'm okay with that. I have just this 5 out front, so I'm just going to leave that guy there. And then I have this root 5 times 7. So making sure I multiply the root 5 out front by both things inside the brackets. All right, so I have this 2 and root 5 and root 3 gives me square root of 15. And then I have this plus 5. And 5 and 7 is 45. 5 and 7 is not 45. I don't even know where that came from. I'm just looking for perfect squares here. I'm going to have to check my math. So there's no perfect squares that go into 35. And there's no perfect squares that go into 15. So I don't have to simplify this any further. There's nothing really I can do to go any further than that. So for a question like letter E here, if you just did this step and just showed that, I'd be okay with that. You don't necessarily need to show the multiplication under the brackets. And as you do more and more of these, you'll get to a point where you probably won't need to. If you want to show that step, that's fine. I'm never going to complain about you showing too much work. I don't think I've ever done that before, complained about a student showing too much work. This is too thorough. I understood this far too well. Don't be so good next time. That doesn't happen ever. All right, so instead of doing a bunch of mediocre, we're just going to dive right into a FOIL type question. So instead of having one thing in front, two things under the bracket, or in the bracket, we're going to do 2 and 2. So FOIL, first, outside, inside, last. Same process. 2 things need to be multiplied by 2 things. So everything needs to be multiplied by everything else in each bracket. I'll try to color code this first one. We'll see how we do. First. All right, so I'm going to go the 3 times the 4. I'm going to write everything out. I have the 3 times the 4, and then I have the root 10 times the 7. So the things in front get multiplied by the things underneath. So there's my first. Outside is the O in FOIL. So I had this negative 3, and then I have nothing here, just a 1. I could write in a 1, but I'm not going to. And then under the brackets, I had or under the radical sign, I should say, I had a 10. Now I have a 5. So 10 times 5. There's my outsides. My insides is going to be these guys. So I'm going to have 4 times 4, and then I'm going to have 6 times 7 under my radical sign. And then I'm going to end up on my lasts is going to be this positive 4 times negative 1 is going to be negative 4, and under the radical I'm going to have 6 and 5. Okay, so let's just do the multiplication now, and then we'll worry about simplifying at the end. So the first one, I have a 3 and a 4 out front. 3 times 4 gives me 12, and under the radical I have a 10 and a 7 is 70. Uh, 10 and 5 gives me 50. I have this 4 and 4, which is 16. 6 and 7 is 42. And then negative 4, and 6 and 5 is 30. So when I add and subtract radicals, if we recall at the very top of this page, let's just quickly scroll up, we can only combine radicals that are the same. So if I have a root 3 and a root 3, I can combine those. If I have like 2 groups of root 3 and another 5 groups of root 3, I can combine them together to give me 7 groups. Here I had these 2 different colors, and I said, okay, 2 root 3 and 6 root 3, that gives me 8. I can't add and subtract radicals if they don't have the same number under the radical sign. I can only add and subtract radicals if I have the same thing under the radical sign. So let's check our answer that we just got here. And I have a 70, a 50, a 42, and a 30. So unfortunately, I can't combine any of those together. But there's one thing that I need to do to finish this question. I'm not quite done. I need to figure out if there's anything I can do to simplify any of my radicals. So there are any perfect squares that go into any of the numbers here. So 70, 50, 42, and 30. Are any of those numbers divisible by perfect squares? So when I talk about that, like 70, 50, 42, or 30, could I pull a 4 out of any of those? So 4, 9, 16, 25, 36, 49, 64, 81. And a little light bulb should go off in your head after you see these sorts of questions again and again and again. 50 is a perfect square that actually divides into 50. So 25 goes into 50 twice. So I need to rewrite all of this. I'm going to break this 50 into a 25 and a 2. I'm going to just rewrite everything else. And I'm going to have this 12 root 70, negative 3, and then the square root of 25 is going to give me 5. So I'm going to pull that out. rewriting everything else. And then I'm going to multiply the 3 and the 5 together. So everything in blue, black, and red, nothing's changing here at all. These are all as simple as they get. The 3 and 5 gives me 15. The 16 root 42 stays the same. Negative 4 root 30 stays the same. And then I look again. Do I have like 72, 42, and 30? These are all different, so I can't combine any of those. Which means that this is as simple as this thing gets now. I make it sound like it's just so easy, just so simple. Obviously not simple, but gives you a bit of an idea of what these types of questions are going to look like. All right, letter G. It looks like nothing we've encountered before. There's this squared outside of the brackets, and you think, oh no, what do I do? Well, let's just stop for a second. If I had something like x squared, what does that really mean? Or if I had something like even x cubed, that just means x times x times x. If I had x squared, that would just be 2 x's, x times x. All right, so keeping that in mind, what do you think this 2 root 5 plus root 6 is going to look like? If I had x squared, I just wrote the same thing twice. That's what I'm going to do here. So instead of writing it as 2 root 5 plus root 6 squared, I'm just going to write it twice. 2 root 5 plus root 6. Now, this is one of the most common places students will make mistakes in Math 10. We're going to deal with questions like this a lot, especially later on in Unit, I want to say 4, but I don't think it's 4. Students will just square both things inside the brackets once we start dealing with exponents. That's not how this mathematically works. If I have x squared, I have to write it x times x. And the same thing goes here. Everything inside the brackets, I need to write it times itself. Now, at this point, there's really nothing different on this question than there is on the previous question we just did. It's a FOIL question. You have two, well, I don't want to call them binomials because there's radicals in here, but you have two terms in each of the brackets. So we're going to have to FOIL these. Something really cool kind of happens as we FOIL them. We end up with some perfect squares, which is kind of convenient, but the process is the same. So let's see if we can't do this. We're FOILing. Firsts. 2 times 2 is 4, and then root 5 times root 5 is root 25. My outsides, I have positive 2 times 1, I'm going to write 2, and then root 5 and 6 is going to give me root 30. My insides, root 6 times 2 root 5 is going to give me positive 2 root 30, and then my lasts are going to be root 6 times root 6, which is positive root 36. So when we square these things, you'll notice that we end up with some like terms, we end up with some perfect squares. There's a lot of simplification we can do here. So I just need to pick one thing I want to do first. So if I kind of stick to my order of operations, I have to do my brackets first. And every time we have a radical, we treat it kind of like brackets. So the square root of 25 is just 5. 2 root 30 I can't really do much with. I have another 2 root 30. I'll end up combining these, but I don't want to get too far ahead of myself. And then the square root of 36 is 6. This 4 and 5 together give me 20. I'll just rewrite everything again. And then I have the square root of 36 of 6, so I just have the 6. All right, so I've simplified my brackets. Now I need to combine any like terms I might have. So do I have like terms? Sure I do. I have this 20 and I have a 6. I can add those together. And then on the inside here, I have 2 groups of root 30, and then I have another 2 groups of root 30. So the 20 and the 6 together give me 26. And then I have 2 groups of root 30, another 2 is 4 times the square root of 30. And that is as simple as I can make that. I can't pull out any other perfect squares. I can't really do much else there. All right, so that's multiplying radicals with the distributive property. I know you've only seen like 3. There's a bunch in the learning guide. Maybe we'll just take a little breather. We'll jump over to the learning guide and kind of take a peek at what that looks like. Then I want to do a few division questions, and then that's all I want to cover because that's all the material there is. Actually, if there's one other thing I can do, just so everybody is aware, there's it's in the learning guide here. I'll jump back to it in a second. All right, what have we done? Where are we? Let's go to the top. So we talked about the real number system, real numbers, irrational numbers, whole numbers, natural numbers, integers. You can go through that stuff. We talked about square roots and estimating where they go on the number line. We talked about perfect squares and estimating roots based on what perfect squares they're between. Did some irrational number stuff where we talked about adding and subtracting radicals, number lines. Then we talked about simplifying radicals next. So instead of writing something like root 18, we'd write that as 9 times 2, which is 3 root 2. So this is the same as root 18. So that was a really, really important idea, number 4. You should be able to do those. And then number 5 was kind of just working backwards, going from 2 times 2 is 4, so the square root of 4 is 2. And then I put them under one radical, 4 times 11, square root of 44. So the square root of 44 is the same thing as 2 root 11. Six, 7, we did some word problems. And then last day, we did some adding, subtracting. And then multiplying, dividing radicals on page, what does this say? Page 9 is kind of where I left, and I said, okay, we can do up to letter F, but you don't know how to do anything after F. So now everything kind of from F on is the distributive property. So root 3 times root 5, root 3 times root 7. Once you get that answer, simplify, you're done. Go on to the next one. We get into letter K, which is the beginning of our FOIL type questions. And then when we get down to something like N, it's extremely important, we'll start next to it, that you write this as 5 root 2 minus 3 root 5 times 5 root 2 minus 3 root 5. So there we go. Get rid of all this mess. See if I can clean this up. It's visible, legible. All right, so what we have left here is the division, then there's a couple word problems. So maybe let's look at a few division type problems, and then we'll, the other question I wanted to look at was this guy up here. There was one question, I'm like, oh, just ignore it, I crossed it off. Where did it go? Forgive me, I will find it. That's not it. That's not it, that's not it. Oh, this guy right here, number 8. Remind me if I forget that I want to show you guys how to do number 8. I'll come back to it. All right, so that's kind of where we're at. We're almost done. There's a bit of stuff left. Let's do some dividing radicals, and then I apologize again, I kind of forgot to include these on the sheet. It's all right. So I wrote down a few questions here that I just want to do together. So in general, we kind of like in math to write like general sort of rules. If we have something like root A divided by root B, we can write that as the square root, big square root of A over B. So just like multiplication, when we had root x times root y, we can write that as root xy. We can do the same thing with division. So instead of writing it as two separate radicals, we could write it as one big one. And there's nothing stopping us from going backwards. If we have one big one, we can write it as two separate ones. So whatever is just the most convenient for us, we just go with it. So it's not terribly difficult. Let's look at just a couple of examples. Let's say I had something like this. Root 16 divided by the square root of 4. I'm actually going to do this one twice. I think it's easier that way. So from what I just wrote up above here, we can write this as, I can write it as 16 divided by 4. And 16 divided by 4 gives me square root of 4, which is 2. So I could do it that way if I wanted, or I could say, okay, the square root of 16 is 4, the square root of 4 is 2, 4 divided by 2 is equal to 2. So I could kind of work in the red, or I can work in the blue. And for everyone, it's going to be a little bit different how your brain works. You're going to think, oh, I have two radicals, one on top and bottom. I'll put them under 1, do the division, then try to simplify at the end. Or for some of us, you can just think like, oh, 16, 4, those are both perfect squares. I'll take the square roots, divide, done. So it doesn't really matter how you do it. If we're kind of sticking with what we've been doing, we've been thinking order of operations. We're treating our radicals like brackets. So, you know, maybe you want to do the square roots first and then simplify after. Doesn't much matter. So that was just obviously a really simple example. Let's look at something a little bit more complicated. If I had 3 root 20 and then I've divided it by 2 root 10. All right. Just want to kind of remember that this 3 root 20 is the same thing as saying 3 times the square root of 20. So what I'm going to do is I'm going to write the 3 and the 2 over one another, and then I'm just going to multiply it by the root 20 over the root 10. So I just kind of broke it up into a fraction and radicals. Get my numbers by themselves, and then my radicals together. And as long as I'm multiplying, I can do this. If I'm adding or subtracting, it doesn't work this way, unfortunately. I'll just keep working across the page just because that's just what I'm doing today. And then I'll put these under one radical sign, like that. And then I know what 20 divided by 10 is. 3 over 2, I can't simplify that any further. That's just going to be 3 over 2. But 20 over 10 is going to give me 2. So I could write this kind of as this, 3 over 2 times root 2. Or I could go, okay, this is a 2 over a 1. If I'm multiplying fractions, I'm going to get 3 times root 2 on the top. And then 2 times 1 is just 2 on the bottom. So you'll likely see this answer written like that. You probably won't see it written like that as the fraction in front of the radical. All right, let's look at one more example, and then I'll do that number 8 from the course, and then I'll give you guys some time to practice these. All right, so we have root 24 over 7 times the square root of 12. Now this is a little bit tricky because there's no number in front of the root 24. So even though there's nothing there, we can just assume there to be a 1 there, because 1 times 24 is, 1 times the root of 24 is just root 24. So I can just rewrite this as 1 over 7 times the square root of 24 over the square root of 12. I'll write it all under one big radical sign. And then 24 divided by 12 is just going to give me square root of 2. So it's going to kind of work out like the one we just did above. So the square root of 2 can be written over 1. And we end up with root 2 over 7. All right, I know I've thrown a whole lot of information at you guys today, and I don't like to cover as much as we did today, as quickly as we did, but it's kind of the nature of this program and whatnot. So what I want to do is I want to just show you how to do number 8 in the learning guide, and I know this is going to be another sort of new idea for you guys to wrap your heads around, but know that when we get into the exponents unit a little later on, we'll come back and do questions like number 8. I don't feel that it belongs in this unit, but it is there, and there will be a few of them on, not a few of them on the test. You might encounter them on the test, so I just want you to be prepared to see them. They're not hard, but I just want you to make sure you've seen them before. So if I had something like a rectangle and the length was x, or square I should say, so the area is going to be x times x, or x squared. Now if I wanted to figure out how long the side length of that was, I would take the square root of x squared and I would get x. So this is the idea we want to think about. If I have the square root of x squared, I get x. I don't think any of you would find that very surprising. The other thing we need to keep in mind when we're dealing with questions like this is if I have something like x times x times x times x, that's the same thing as x to the power of 4. I just add up the ones. 1, there's another one, there's a 2, a 3, and a 4. Or if I had something like x squared times x squared, again, I just add them up and I get x to the power of 4. I could write this again as x to the power of 3 times x, which is x to the power of 4. So I can write it this way, I can write it this way, or I can write it this way. They're all x to the power of 4, just written different ways. So keeping those two things in mind, two things you've seen before, we're going to kind of think about it in terms of this example. So the trick with these questions is you always want to write down the powers that you have in groups of 2, because if I had something like the square root of a squared, that's just going to be a. So if I have a to the power of 6, that's a squared times a squared times a squared, and then this b is going to be b squared times just b, because I have 3 of them all together. The reason I do this is because I can take the square root of a squared and get a. I can do that a bunch of times. So I'm just going to ignore the 52 for now. I have the square root of 52. So this a squared a squared and a squared. If I take the square root of a squared, I get a. So essentially, I'm just taking the a out of the brackets, or out of the, and then I end up with a b, because I can take the square root of b squared and get b. And then what's left under my radical sign? 52 and a b. That's what's left. Here's my 52 that I didn't take the square root of, and then the b. Now I know that's going to be like a huge stretch for some of you to kind of wrap your heads around that. Now I can combine the a's back together and I get a cubed times b is 52 times b. And then I think, is there any perfect squares that go into 52? Can I simplify 52 at all? All right, so 52 divided by 16, that's 3.25, that doesn't work. 52 divided by 36, no, that doesn't work. 52 divided by 4, that works. So now I need to do another step here and take this 52 and break it down further. So a cubed, b, 52 I'm going to break into 13 times 4. And then I can take the square root of this 4 to get 2. So I'll just continue up here. So the a cubed stays there. The b stays there. I have a 2 now because I took the square root of the 4. I have a 13 and a b. So I would write this as 2a cubed b times the square root of 13b. If I haven't lost you there, holy cow, you're smart. If I have, no worries. You can try B and C if you want, but like I said, this stuff doesn't really fit here very well. It's just kind of things that should be later on in the course. So I'm going to leave that there. That's all I want to talk about. That now kind of prepares you for everything you're going to encounter in the learning guide. So you can do all of these addition and subtraction. You can do the multiplication stuff. Rationalizing the denominators. I can't throw any more stuff at you. Let's leave 3 for next day. That'll be the last thing I do before you guys finish off Unit 3. Unit 1. Rationalizing the denominator. What this means is can't have a radical in the bottom. So if we have a fraction, you can't have a square root on the bottom, and I'll teach you how to get rid of those. So you can just not worry about 3 for now. You can do 4, you can do all these word problems. That's really it. So in terms of a timeline, today is kind of a wrap-up of most things except for question 3. I don't want to give you guys any more stuff because I know your brains are about to explode. Today is, what's today? Today is Thursday. I won't see you until Tuesday next week. And on Tuesday next week, I'll go through question 3, rationalizing denominators, but you should be done everything on Tuesday next week. So you should be ready to write the test on Tuesday next week. The only thing you won't have seen is this number 3 on page 10. Rationalizing denominators. So the due date of the unit and the test will be next Tuesday. I will expect you to be done everything except question 3, and then after I show you how to do 3, it's only one thing. We'll probably move on to unit, let's see, we started in 2, now we've done 1, so we'll actually move into unit 3 next, which is kind of confusing, but yeah, so next class, I'm going to answer any questions that you ran into troubles with from the learning guide. I'll show you how to do number 3, which will only take like 5 minutes. It's really, really easy. And then I will kind of expect that you guys are ready to submit this learning guide next Tuesday. So you should have everything in this learning guide done except for question 3 on Tuesday next week. I'll expect that you write the test on either Tuesday or Wednesday next week, and that's kind of where we're at, which takes us into a bit of Unit 3, and I'm not meaning to get too terribly far ahead of myself, but next week and then the following week is November 3rd, as our in-class exam where you guys come into McWilliams Center on November 3rd and write the first midterm, because that's the end of our first term. So on November 3rd, you guys are going to come in, you'll write a test on, I don't know how much, units 1 and 2 for sure, and then maybe a bit of 3. I don't know how much unit 3 we'll get to though. So for the midterm, units 1 and 2 will have to be on that midterm exam, and then maybe a bit of 3. So kind of prepare for that as well. I apologize for throwing so much stuff at you guys today, but I think you guys can do it. You will have some work ahead of you here between now and next class, but it's Thursday and next day, so you have 5 days and a weekend, and there's no field trip on Friday tomorrow because we have professional development day again. So you guys have some time, so come back next class. How long is the midterm usually? I'm going to make it probably around 20 questions. You guys will do it in an hour. It's not like a high pressure scenario or anything. You guys write your tests at home, and it's nice for you guys to come in and see me. And I like the company. It's kind of lonely here sometimes. So it'll be about 20 to 30 questions, maybe some multiple choice, some written. I'm going to plan on it taking you guys an hour to do. So it's nothing to be stressed out about. It'll be questions from the test bank that you guys have encountered already. So you might see questions you've already seen on tests and quizzes. It's not meant to be difficult. It's just, what do you know? Do you not know stuff? Like, how much of units 1 and 2 do you know? Sort of idea. So I'll talk more about it next week as we get a little bit closer to the Thursday midterm. But just so you know, it's a couple weeks out, and I want you guys to be prepared. For sure, yeah, formula sheet, of course, Eric. So when you guys come in to write the midterm, all you need is a pencil and a calculator. And I'll have the test pages for you to write on, and scrap paper, and a formula sheet. So yeah, you just need to come with a pencil and a pencil and a calculator, and everything else will be here. The test and formula sheet and everything else. So there you go. Next day, done unit 3 on Tuesday next week. I won't see you guys tomorrow, but I hope you guys have a good weekend. Come with questions, and we'll talk about rationalizing denominators. If you really want to kind of master all of this stuff before Tuesday next week, then you can find the little video built into the course on rationalizing denominators. It's pretty straightforward. Can we listen to music, Jesse? Yeah, I don't have issue with that. The only thing that a lot of you guys will use your phones to play the music. So there's kind of, I don't want you guys to cheat. I don't want you to have to hit your phone when you're listening to music. So if you've got a good playlist, it's an hour long, and you just press play and set it and forget it, then I have no issues with that. So yeah, that's fine. You can bring headphones if you like. So there you have it. I'm going to leave you guys there. I hope you guys have a great weekend, and we'll finish up this next Tuesday. So have a good one. Bye-bye.